So you've learned about the control plane and master node. Now let's focus on the worker nodes. So as I said before, the worker nodes, this is where the heavy lifting work happens. So the worker node is a VM or a physical machine often running Linux. It provides the running environment for your applications. So this is our worker node, and inside we have the applications. So right here, so we have a pod, and you're going to learn about pods later, but this is for now, you can think of a pod as a container in the Docker world. And one thing to note here is that when deploying your applications, you should really be deploying microservices. So here we have 3 microservices, so microservices A, B, and C. If you want to deploy monolithic applications, then you should really be considering splitting into small microservices, because this is where Kubernetes does shine. And also microservices is the standard these days, and this is where the industry is moving. So moving on to worker nodes, the worker node has 3 main components. So if we look into it, so here we have the worker node, and inside of each worker node we have the kubelet, which is an agent, and you're going to learn in a second what it is. You also have the container runtime. I'm going to explain this in a second as well. And also we have the kube proxy. And remember, I said that the node itself is actually a VM or a physical machine. So in this example, let's say that this is a VM which runs Linux with 4 cores, 32 gig of RAM, and 100 gigabytes of SSD storage. So you can see that this node has 3 components: kubelet, container runtime, kube proxy, and it runs on Linux. So let's learn about the kubelet. So the kubelet is the main agent that runs on every single node. It receives pod definitions from the API server. It also interacts with the container runtime to run containers associated with that pod, and it reports node and pod state to the master node through the API. So here you can see that the API talks to the kubelet, and the kubelet also talks back via the same channel, and the kubelet also interacts with the container runtime. So what is this container runtime? Well, the container runtime is responsible for pulling images from container registries such as Docker Hub, GCR, ECR, and ACR. So these are some of the popular ones. But basically, it's responsible for pulling images, starting containers from those images, and also stopping containers. So the main thing here is that it's responsible for running containers, and it abstracts the container management for Kubernetes. And within it, we have the container runtime interface, and this is an interface for third-party container runtimes. So you might have heard that Docker was recently deprecated by Kubernetes, and this is because it's in favor of Containerd, which is becoming now the standard container runtime for Kubernetes. So let me quickly show you. So right here, I'm inside of the Containerd official page, and you can find the link for this website under the description of this video. And you can see that they say it's an industry standard container runtime with an emphasis of simplicity, robustness, and portability. And as of the 28th of February of 2019, Containerd became part of the Cloud Native Computing Foundation, following Kubernetes, Prometheus, and others. So basically, you can see that they explain the ecosystem in here. And right here, you can see that we have the kubelet, and right here we have the container runtime. And here they say that it manages the complete container lifecycle of its host system, from image transfer and storage to container execution and supervision of low-level storage to network attachments and beyond. So I'm going to leave the link for this page right here. You can see the adopters. So IBM Cloud Kubernetes Service, Google Cloud right here, Docker as well, Instana, Firecracker, and others. So go ahead and check this link to learn more about Containerd. If I go back to the slides and move on to the last component within the worker node, which is the kubeproxy. So the kubeproxy is an agent that runs on every node through a daemon set, and it's responsible for local cluster networking. It makes sure that each node gets its own unique IP address, and it's also responsible for routing network traffic to load balance services. So you're going to learn about all of this in a second. So for example, if two pods want to talk to each other, so kubeproxy is what's doing the magic. If you as a client wants to send a request to your cluster, kubeproxy is responsible for handling all of that. So there you have it. Now you know about the three main components within the worker node. And also you've learned about the control plane, which gives you the complete picture of the entire Kubernetes architecture. So knowing all of these components and how they work together will make you understand everything once we start using Kubernetes. If you have any questions, go ahead and drop me a message. Otherwise, let's move on.